to talk about a new rule in order to find a derivative that we haven't discussed yet. But before we get there, let's look at this question. I'm asking you to use x squared and x cubed. And we're going to do a couple things with those. The first is that we're going to multiply the functions together. Let me actually just give this a name. I'll call it y. And then find the derivative. So we know the derivative here is going to be 5x to the fourth. The second thing I ask you to do with the same two functions is to actually take the derivative of each of them separately. So here's the derivative of x squared and the derivative of x cubed, and then multiply them together. And I haven't created a name for this, but really what I'm most interested in is the fact that these are not giving me the same answer. So what we're figuring out here is that I cannot just take the derivative when I have a product. Let me say that again. When I have a product of two functions, I cannot just take the derivative of one of them, the derivative of the other, and multiply them together to get the correct answer. We know this is wrong. We've done enough derivatives to know this one is correct. So let's talk about what we are allowed to do. There's a lot of writing on this page. Feel free to pause the video in order to kind of catch up with the notes. What you see first, though, is the product rule. So we're in 4.2 right now. And just look at the pieces that we have here. So we're saying we want the derivative of two things that are being multiplied together. We're calling them f of x and g of x. And notice that in the derivative, I see f of x and g of x show up. I also see their derivatives show up. Here's g's derivative and f's derivative. So the product rule is saying that's how you could work with the pieces. And if you add those pieces together, you'll end up with the derivative of f of x times g of x. Notice the addition symbol, and so it wouldn't actually matter if we had switched these around, being that addition is going to be commutative. This other notation written below is just another common notation. Sometimes I hesitate to show it just because you can probably imagine that some people's u's and v's kind of look alike. So just be careful with that if you choose that notation. Again, feel free to pause this as you go along. Let's look at this example of a product. And there's actually three things being multiplied together here, but I'm going to approach it as two things. I'm going to approach it as the 3 times the x as one idea, and the sine of x as another idea. So that's going to be my f of x and my g of x. And I want the derivative of them. So according to the product rule, if I want to find the derivative, I'm just going to write f of x, and then I'm going to write the derivative of the other function. Derivative of sine of x is the cosine of x. Throw in that plus symbol. And then I need just g of x, not the derivative of g of x. Well, g of x was the sine of x. And finally, I need another derivative, which was of the first piece. Derivative of 3x is 3. So one way I could write this would be 3x cosine of x plus, probably put that 3 in front of the sine. Or maybe you factor out the 3 to this problem. Here's another example. Why don't you see if you can figure out the answer? So pause it at this point, and then come back to this. All right, let's see if you got the correct answer. So I'm approaching this as I've got my f of x and my g of x, where here's one of my functions, and here's the other function. So there's my product. Yes, I have this minus 5x here, but I know how to take the derivative of one piece minus another piece. That's my old derivative rules. I get to just take the derivative of each of them separately. But I need the derivative of this first part, this part that I've got highlighted here. And in order to take the derivative of that, since it's a product, I'm going to need to write x squared and the cosine's derivative. And then I need to write cosine and x squared's derivative. And product rule says there'll be a plus in there. Now don't forget about this negative 5x. I still need its derivative. So that's going to be minus 5 tacked on to the end. Other things to be careful about is these parentheses need to be here. Otherwise you'd have x squared minus the sine of 5x. I'm sorry, x squared minus the sine of x. You want the whole thing to be multiplied. So it looks like I'm getting x squared, let's make that negative x squared, sine of x, plus 2x cosine of x, minus 5 as my answer. And that would be dy dx, or as I've written here, y prime.